Welcome to a lesson on double angle identities. The goal of the video is to use double angle identities to determine function values. So the first thing you'll notice is there are three double angle identities for cosine. Cosine of 2a is equal to cosine squared a minus sine squared a, or 1 minus 2 sine squared a, or 2 cosine squared a minus 1. All of these are equal to cosine of 2a. And for sine and tangent, there's only one double angle identity. Sine 2a is equal to 2 times sine a times cosine a. Tangent 2a is equal to 2 times tangent a, all over 1 minus tangent squared a. Let's take a quick look on how these can be verified. If we take the sum identity for cosine, and instead of using a plus b, use cosine of a plus a, we can see how cosine 2a is equal to cosine squared a minus sine squared a. Now taking cosine squared a minus sine squared a, we can replace sine squared a with 1 minus cosine squared a and obtain 2 cosine squared a minus 1. Or if we now replace cosine squared a with 1 minus sine squared a, we can obtain 1 minus 2 sine squared a. So you may want to pause the video and take a closer look at this. Next, for the sine of 2a, again we'll use a sum identity, and instead of using a plus b, we'll use a plus a, and we can obtain 2 times sine a cosine a. And lastly, for tangent, we'll use the sum identity again with angle a plus angle a,
and we obtain 2 tangent a divided by the quantity 1 minus tan squared a. You may want to pause the video and take a closer look.
Let's go and take a look at a couple problems. Here we have sine a equals 3/5 in quadrant 2. We want to find the exact value of cosine 2a, sine 2a, and tangent 2a, and then determine the quadrant of angle 2a. So if we go over here and look at the identities, we can find cosine 2a with just the given information since we do have sine a. So let's go ahead and find that first. So we have 1 minus 2 times sine squared a. Well, if sine a is 3/5, we'll have 3/5 squared. And we'll go ahead and simplify this. 3/5 squared would be 9/25 times 2 would be 18/25, which gives us 7/25 for cosine 2a. Next, let's try to find sine of 2a. Now there's only one identity for sine 2a, and right away we can see we're going to have to find the cosine of angle a. So let's take a closer look at angle a with a sine of 3/5 in the second quadrant. This would be our angle a, and so we'll draw our reference triangle. Here's our reference angle. And again, this angle has a sine of 3/5, so opposite over hypotenuse. So this is a 3, 4, 5 right triangle. Since we're in the second quadrant, we'll label this -4. So now we know that sine a is given as 3/5, and cosine a equals -4/5. So going back to sine of 2a, we'll have 2 times sine a, which is 3/5, times cosine a, which is -4/5. So we can put this over 1. Our denominator is 25. 2 times 3 times -4 will be -24. So the sine of 2a is equal to -24/5. Lastly, let's find tangent 2a. So again, look at our formula, and we have to find the tangent of angle a. Well, here's a reference angle for angle a. The tangent of angle a would be opposite over adjacent, or 3 over -4. So tangent a equals -3/4. So we'll have 2 times tangent a, or 2 times -3/4 over 1 minus -3/4 squared. Let's go ahead and simplify this. -3/2 in the numerator, and our denominator is going to be 1 minus, now this square would be 9/16, so 1 minus 9/16 would be 7/16. And then lastly, this would be the same as -3/2 divided by 7/16, but instead of dividing, we'll multiply by the reciprocal, so times 16/7. And again, simplifying, and we have -24/7 for the tangent of 2a. And again, we could have just taken sine of 2a over cosine of 2a to obtain -24/7, but I wanted to go ahead and use the identity. Okay, the last question deals with what is the quadrant of angle 2a. So let's take a closer look at that. We know the given angle was in the second quadrant, so angle A is between 90 and 180. So angle 2A, multiplying each of these by 2, this tells us that angle 2A would be in quadrant 3 or quadrant 4. So to determine which quadrant it would be in, we can take a look at the signs of cosine 2A, sine 2A, and tangent 2A. Well, right away we know that the cosine of 2A is positive. Well, if cosine 2A is positive, we have to be in the fourth quadrant because we know the x-coordinate has to be positive. Therefore, we know angle 2A must be in the fourth quadrant instead of the third quadrant. Let's take a look at another problem. Here we're going to use the identities in the reverse order. We want to determine the cosine of angle A given we know that cosine 2A is equal to -3/4 and terminates in the third quadrant. Looking at our identities, we can find cosine of angle A if we know cosine of 2A using this identity. Let's give it a try. So the cosine of 2A is -3/4. So we'll solve this equation for cosine A. Let's go ahead and add 1 to both sides. -3/4 plus 1 would give us 1/4. Let's go ahead and add 1 to both sides. That would give us 1/4 on the left equals 2 cosine squared A. Now we'll divide by 2, or we can multiply by 1/2, same thing. That will give us 1/8 equals cosine squared A. Now we can take the square root of both sides. This will give us cosine of angle A is equal to plus or minus square root of 1 is 1. The square root of 8 simplifies to 2 square root 2. Now notice we're going to have to determine whether it's going to be a positive or negative value for cosine A. So let's go back to the problem. It says angle 2A terminates in the third quadrant. Well, if an angle is in the third quadrant, it must be between 180 degrees and 270 degrees. So to determine the terminal side of angle A, we can divide everything by 2, and we can obtain that angle A is between 90 degrees and 135 degrees, which would put angle A in the second quadrant. And the second quadrant, the x-coordinate is negative, therefore our cosine value would be negative. So what we know now is that cosine of angle A is equal to -1/2 square root 2. Now let's go ahead and rationalize this just to be consistent. This would give us negative square root 2 in the numerator, and this would give us square root 2 times square root 2 would give us 2 times this 2 would be 4. And I think we have it. Cosine of angle A is equal to negative square root 2 divided by 4. Okay, I hope you found this video helpful. Thank you for watching and have a good day.
In this example, we're given that cosine theta equals -5/13 and theta is in quadrant 2. We want to determine sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Looking at our identity for sine of 2a, sine 2 theta equals 2 sine theta times cosine theta. So let's go ahead and create the reference triangle for angle theta in the second quadrant so we can determine the other trig function values for angle theta. We know the terminal side of the angle is in quadrant 2. So here's our reference triangle. So here's our angle theta in the second quadrant. And we'll call this our reference angle, theta prime. And the cosine of this angle is -5/13. So the adjacent side would be -5, the hypotenuse would be 13. And we can determine the length of this leg here using the Pythagorean theorem, but this is a 5, 12, 13 right triangle, so we can label this leg here 12. Notice the y-coordinate is positive and the x-coordinate is negative. So from here we know that sine theta is equal to 12/13 and tangent theta is equal to 12 divided by -5 or -12/5. This is all the information we need. Now we can just apply the correct double angle identity. So for sine of 2 theta, we're going to have 2 times sine theta times cosine theta. So we'll have 2 times sine theta is 12/13, and cosine theta is negative 5/13. Let's go ahead and put the 2 over a 1. Nothing here simplifies, so we'll multiply across the top and bottom. 13 times 13 is 169. 2 times 12 is 24. 24 times negative 5 is equal to negative 120. So sine 2 theta is equal to negative 120 divided by 169. To determine the value of cosine 2 theta, notice we have 3 different options. Let's go ahead and just use the first identity. So cosine of 2a is equal to cosine squared a minus sine squared a. So cosine 2 theta is equal to cosine squared theta, which will be negative 5/13 squared, minus sine squared theta, which is 12/13 squared. So here we're going to have 25 divided by 169 minus, this is 144 divided by 169. So we have common denominator, and now we have 25 minus 144, which is equal to negative 119. To determine tangent of 2 theta, we could use this identity here, but since we already found sine 2 theta and cosine 2 theta, tangent 2 theta is equal to sine 2 theta divided by cosine 2 theta. So there's no need to use this identity here if we already have sine 2 theta and cosine 2 theta. It's going to be equal to negative 120 over 169 divided by negative 119 divided by 169. And then we can just multiply the numerator by 169 and the denominator by 169. Might be helpful to put these over 1. So we can see that this simplifies out, this simplifies out. So we're left with a positive 120 divided by 119. But I think I'll also show we can get the same value by using this identity here, just in case you're required to show this. So tangent 2 theta is going to be equal to 2 times tangent theta, or 2 times negative 12/5. Put this over 1, divided by 1 minus tangent squared theta. So we'll have 1 minus negative 12/5 squared. So our numerator is going to be negative 24/5 divided by, here we're going to have 1 minus 144/25, which equals negative 24 over 25, divided by, this difference here is negative 119/25. And now if we write this division problem as a multiplication problem, we're going to have negative 24 divided by 5 times the reciprocal of our denominator here. So we'll have negative 25 all over 119. Here we have a common factor of 5. And a negative times a negative is positive, so we'll have 24 times 5, that's 120. And our denominator is 119. So you can see why I chose to take the shortcut, but obviously the result is the same for tangent 2 theta. I hope you found these examples helpful. In this video, we'll use double angle identities to simplify and then evaluate the following expressions. So this first expression is cosine squared pi divided by 12 minus sine squared of pi divided by 12, which fits the form of this first identity. Notice on the right side we have cosine squared a minus sine squared a is equal to cosine of 2a. So for the first expression, a is equal to pi over 12. So we can rewrite this as cosine of 2a, or cosine of 2 times pi over 12. Put the 2 over 1. This simplifies. So we have a cosine pi over 6. which is a 30-degree angle. Let's go ahead and sketch our reference triangle. And the cosine of 30 degrees is square root 3 divided by 2. For the second expression, we have 2 cosine of pi over 4 times cosine pi over 4, which fits this double angle identity for sine. Notice we have 2 sine A cosine A on the right side, which is equal to sine of 2A. So A is equal to pi over 4. So this is equal to sine of 2A, or 2 times pi over 4. Again, this simplifies nicely. So this equals sine of pi over 2, which is equal to 1. And we can verify this if we need to on the unit circle. Here's pi over 2 radians. On the unit circle, sine theta is equal to y. So sine pi over 2 is equal to 1. In our last example, we have 2 cosine squared pi over 2 minus 1, which fits the form of this identity here, where a is equal to pi over 2. And so this right side is equal to cosine of 2 times a. So we have cosine of 2 times pi over 2 is just going to be pi. And cosine of pi is equal to negative 1. And again, if we need to, we can verify this on the unit circle. Here's the terminal side of pi radians. Cosine theta is equal to x. So we have a cosine function value of negative 1. In this example, we're given that tangent theta equals 2/3 and sine theta is less than 0. We want to determine sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So we'll be using the double angle identities we see here below, but we first need to determine sine theta and cosine theta from the given information. Tangent theta is equal to 2/3, which means the terminal side of theta must either be in the first quadrant where both the x and the y coordinates are positive, or the third quadrant where both x and y are negative. Remember, a negative divided by a negative is still positive. The reason they're telling us that sine theta is less than 0 is because if sine theta is less than 0, then y is less than 0, meaning y is negative. And if y is negative, then x also has to be negative in order for the tangent function value to be positive. So the terminal side of our angle theta is going to be in the third quadrant. So let's go ahead and sketch a reference triangle in the third quadrant. Doesn't need to be to scale. This would be our reference angle. And since tangent theta is equal to positive 2/3, the opposite side could be labeled negative 2, and the adjacent side would be labeled negative 3, resulting in a positive tangent function value. Now we need to determine the length of the hypotenuse using the Pythagorean theorem. So let's go ahead and call this r. We're going to have r squared is equal to negative 2 squared plus negative 3 squared. So we have r squared equals, this will be 4 plus 9, so that's 13. Now we can take the square root of both sides. So r is equal to the square root of 13. Remember, r is always positive. So now we can replace r with square root 13. And we needed this information to determine sine theta and cosine theta. So sine theta is equal to negative 2 over square root 13, and cosine theta is going to be equal to negative 3 divided by square root of 13. We're not going to rationalize these unless we have to when applying the double angle identities. So for sine 2 theta, we'll be applying this identity here. So sine 2 theta is going to be equal to 2 times sine theta times cosine theta. So we'll have negative 2 divided by square root of 13 times negative 3 divided by square root of 13. Let's put this 2 over 1. Nothing here simplifies. We'll multiply across the numerator and across the denominator. Here's the reason why we didn't have to rationalize. Square root of 13 times square root of 13 is just 13. In the numerator we have 2 times negative 2 times negative 3. That's going to be 12/13 for sine 2 theta. Now for cosine 2 theta we have a choice of identities. Let's just go ahead and use this one here that involves cosine theta. So cosine 2 theta is equal to 2 times cosine theta squared. So we'll have negative 3 over square root of 13 squared minus 1. Let's go ahead and put this over 1. Let's go ahead and start by squaring this. we're going to have 9 over 13. So 9 over 13 times 2 over 1 is going to be 18/13 minus 1, which is 13/13. So we have a common denominator of 13, and 18 minus 13 is equal to 5. So cosine 2 theta is equal to 5/13. Using the reciprocal identity, tangent theta is equal to sine theta divided by cosine theta. Tangent 2 theta would be equal to sine 2 theta divided by cosine 2 theta. So we could apply this identity here, but we can also use the quotient identity to simplify our work. This would just be 12/13 divided by 5/13, which is the same as 12/13 times the reciprocal, which is 13/5. The 13s simplify out, and we're left with 12/5 for tangent 2 theta. Now I'll go ahead and apply this double angle identity anyway, but you can see this is pretty straightforward if we already have sine 2 theta and cosine 2 theta. But using the identity, we would have tangent 2 theta is equal to 2 times tangent theta, or 2 over 1 times 2/3, divided by 1 minus tangent squared theta, which is 2/3 squared. So we'd have 4/3. This is going to be 1 minus 4/9, which will be 5/9. Writing this as a multiplication problem, we'll have 4/3 times 9/5. This simplifies, and of course the result is the same. This is 12/5 for tangent 2 theta. So regardless of which method we use, the result is the same. I hope this was helpful.
Select an identity from the list on the right for the given expression. We are given the expression the quantity 1 minus cosine 2x divided by sine x. To answer this question, we will try to simplify this expression as much as possible and then see if we find a matching expression. To begin, we will perform a substitution for cosine 2x. Looking at the identities below, though, we have three choices. Because the denominator is sine x, let's write everything in terms of sine using the identity cosine 2 theta equals 1 minus 2 sine squared theta, which means in our case cosine 2x equals 1 minus 2 sine squared x. But because we're subtracting cosine 2x, we need to subtract the quantity 1 minus 2 sine squared x, which means the given expression is equal to 1 minus, and then in parentheses we have the quantity 1 minus 2 sine squared x. And all this is divided by sine x. The next step is to clear the parentheses by subtracting this quantity, or if it's helpful because of the subtraction, we can think of distributing a negative 1. We have 1, and then distributing negative 1, we have negative 1 times positive 1, which is negative 1, which gives us minus 1. And then we have negative 1 times a negative 2 sine squared x, which is positive 2 sine squared x, which gives us plus 2 sine squared x. And this is still divided by sine x. Simplifying, 1 minus 1 is equal to 0, which gives us 2 sine squared x divided by sine x. And notice how we do have a common factor of sine x between the numerator and denominator, which means this sine x will simplify to 1, and the sine squared x simplifies to 1 factor of sine x. Or if it's helpful, we can expand sine squared x by writing it as sine x times sine x. So this is equivalent to 2 sine x times sine x divided by sine x. And in this form, sine x divided by itself simplifies to 1, leaving us with 2 sine x. So the given expression simplifies to 2 sine x, which, looking at the choices, is an option. We select 2 sine x. I hope you found this helpful. We are asked to simplify the given trig expression. To simplify the expression, we will multiply out the numerator. In the denominator, we will convert cotangent t to sines and cosines, and then perform a substitution for sine 2t. Let's prepare to multiply out the numerator. And there are no shortcuts. We
we will have two factors of sine t minus cosine t and two factors of cosine t plus sine t. Again, because we are squaring the quantity sine t minus cosine t, we have two factors of sine t minus cosine t, and because we are also squaring cosine t plus sine t, we have two factors of cosine t plus sine t. In the denominator, cotangent t is equal to cosine t divided by sine t. And then we have times 4 sine 2t, and since sine 2t is equal to 2 sine t times cosine t, we have 4 times 2 sine t times cosine t. Going back up to the numerator, here we have 4 products, 1, 2, 3, and 4. Here we also have 4 products, 1, 2, 3, and 4. Once we find the two products, we will have to find the difference. Sine t times sine t is sine squared t. And then we have sine t times negative cosine t, which is negative cosine t sine t. But notice how the next product is also negative cosine t sine t, and therefore we have minus 2 cosine t sine t. And then we have negative cosine t times negative cosine t, which is positive cosine squared t, which gives us plus cosine squared t. So there's the first product, and then we have minus this product. Cosine t times cosine t is cosine squared t. The next product is cosine t times sine t, which is cosine t sine t. And notice how the next product is also cosine t sine t, and therefore we have plus 2 cosine t sine t. And for the last product, we have sine t times sine t, which gives us plus sine squared t. In the next step, we will find this difference by looking at the denominator. Notice how we can simplify this product. Sine t divided by sine t simplifies to 1, giving us cosine times 8 cosine t, which gives us 8 cosine squared t. Going back up to the numerator, let's find this difference. We have sine squared t minus sine squared t, which is 0. And then we have cosine squared t minus cosine squared t, which is also 0. And then finally we have negative cosine t sine t minus 2 cosine t sine t, which gives us negative 4 cosine t sine t. So we have negative 4 cosine t sine t divided by 8 cosine squared t. Notice how there's a common factor of cosine between the numerator and denominator, and therefore this cosine t simplifies to 1, and the cosine squared t simplifies to 1 factor of cosine. And we know negative 4/8 simplifies to negative 1/2. This is equal to negative 1/2, and then we have sine t divided by cosine t, which is equal to tangent t. The given expression simplifies to negative 1/2 tangent t. I hope you found this helpful. Select an identity for the given expression. We have 2 cosine 2x divided by sine 2x. Since cotangent theta equals cosine theta divided by sine theta, the given expression is equal to 2 cotangent 2x, but 2 cotangent 2x is not one of our choices, and therefore we'll perform a substitution for cosine 2x and sine 2x, and then simplify to see if we can find a matching expression. Beginning with the given expression, let's first perform a substitution for sine 2x because there is only one double angle identity for the sine function. Sine 2 theta equals 2 sine theta cosine theta, and therefore we will substitute 2 sine x cosine x for sine 2x. Now let's perform a substitution for 2 cosine 2x. Notice how for cosine 2x we have three choices. Because the denominator contains both sines and cosines, let's use the identity that contains sines and cosines as well. Let's use the identity cosine 2 theta equals cosine squared theta minus sine squared theta. Or in our case, cosine 2x equals cosine squared x minus sine squared x. And therefore the numerator becomes 2 times the quantity cosine squared x minus sine squared x. We'll notice how 2 divided by 2 simplifies to 1, giving us the quantity cosine squared x minus sine squared x divided by sine x cosine x. From here, because we have a difference in the numerator, let's write this as two fractions and then simplify the two fractions. This expression is equivalent to cosine squared x divided by sine x cosine x, and then minus sine squared x divided by sine x cosine x. Notice how the first fraction has a common factor of cosine x that will simplify out between the numerator and denominator. The cosine x in the denominator will simplify to 1, and the cosine squared x in the numerator will simplify to 1 factor of cosine x. Notice this fraction contains a common factor of sine x between the numerator and denominator that will simplify to 1. The sine x in the denominator simplifies to 1, and the sine squared x in the numerator simplifies to 1 factor of sine x. So the first fraction simplifies to cosine x divided by sine x, and the second fraction simplifies to sine x divided by cosine x. And cosine x divided by sine x is equal to cotangent x, and sine x divided by cosine x is equal to tangent x. So now we know the given expression is equal to cotangent x minus tangent x, which is one of the choices, in this case the last choice. I hope you found this helpful.